A woman called the police to chase down a school bus to retrieve an apple from her daughter's lunch. Why? She'd heard about a growth regulator that contained carcinogens, which are cancer causing agents. This one was called Alar, and at the time, Alar was frequently used on apples and apple products. Needless to say, human beings are terrified of cancer, and they should be. Following close behind heart disease, it's the second leading cause of death in the United States. So, what's causing this epidemic, and what can we do about it? First, let's look at how cancer growth begins. Cancer has three stages: initiation, promotion, and progression. They can be described by the analogy of a typical urban lawn. In initiation, carcinogens produce the first few cancerous cells. They come from processed foods, alcohol, cigarettes, industrial byproducts, and sometimes they're found naturally in nature, like the carcinogen aflatoxin, which we'll get back to later. Your body converts the carcinogens with the help of enzymes, leaving a byproduct that attaches itself to the DNA in your cells. If the cells are not repaired by the body, genes in the DNA are permanently changed and will be passed down to its offspring or daughter cells. The daughter cells reproduce with this new mutation, which continues to spread as the cells reproduce. Thus, the seeds have been planted. The process of initiation is considered irreversible. In promotion, the cancerous cells grow and multiply until they become detectable tumors. This is a process that can take years or months. It all depends on your levels of promoters and anti-promoters. Promoters are factors of a diet that feed cancer's growth, like adding fertilizer to the grass seedlings that you have. Anti-promoters, on the other hand, are the opposite and will slow or stop the rate of cancer growth if there are more of them than the promoters. The final stage, progression, is the growth of cancer cells to the point where they have inflicted damage upon the body. Think of this as the grass growing past its intended patch and invading the sidewalk, shrubbery, and driveway, killing them or making them useless. The cancer is now called malignant because it's causing bodily harm. Eventually, clumps of the cancer cells will break off of the tumors and spread to other regions of the body. This is called metastasizing. After the cells have metastasized, there's virtually no hope for the individual and they die. Now that you know the fundamentals of cancer growth, we can make connections to cancer and our diet. Two groups of mice were fed the natural carcinogen aflatoxin to simulate humans' intake of carcinogens. One group was placed on a low protein diet of 5%, and the other a high protein diet of 20%. The low protein diet mice were found to have 76% less enzyme activity than a high protein diet. This means that a low protein diet decreases the enzyme's ability to break down aflatoxin, and if it can't break down the aflatoxin, there are less dangerous byproducts around to attach themselves to the DNA, thereby preventing the initiation stage of cancer. Another part of the study focused on the second stage of cancer. In other words, the cancer cells were already in detectable masses of starter tumors called foci. One mice group was fed high levels of aflatoxin with a low protein diet of 5%, and the other was fed low levels of aflatoxin with a high protein diet of 20%. So what did they find? The high aflatoxin, low protein diet had significantly less foci growth than the low aflatoxin, high protein diet. This suggests that the protein we eat impacts the growth of cancer cells more than the level of carcinogens in the body. More protein equals more foci and tumor growth. And this makes protein a promoter because it's a factor of a diet that feeds cancer's growth. After the foci or tumors have formed in the body, there is no way to reduce or kill them. However, switching one's diet so that it is lower in protein would slow or stop the cancer growth, as seen in the study with the lab mice. So, how much protein is too much? Keeping your intake at no more than 12% protein should do the trick. Any percentage above 12% showed an increase in foci and tumor growth. Here's the problem the average American has. They usually eat a 15 to 60% protein diet, and in places where they're consuming high levels of protein, and it's just normal, like Texas, their protein diet is even more drastic. Carcinogens are guaranteed to enter the body somehow in different amounts, but keeping protein levels below 12% will prevent or greatly reduce their processing, and therefore prevent or greatly reduce their cancer-causing byproducts. Still attached to the idea of getting more than 12% protein in your diet? Then it's important to note that not all proteins are equally cancer-causing. Soy and wheat plant proteins were used for a group of mice in a 20% protein diet. We already know animal protein would have increased cancer growth. However, the plant proteins showed no foci or tumor growth whatsoever, meaning that it is not a cancer promoter. Let's recap this video's content to give you the big takeaways. Number 1, cancer forms in 3 stages: initiation, where initial cancer cells are produced; promotion, where cancer cells grow until they have formed detectable masses; and progression, where the cancer has become malignant, harming the body, and the cancer cells are metastasizing, which is breaking off and traveling around the body. Number 2, consuming above 12% protein in one's diet allows carcinogens to cause cancer development in the body and will cause foci or tumor growth. The average American diet has 15 to 16% protein. Having a high animal protein diet is worse than having a high intake of carcinogens because animal protein is that fuel. It's the promoter. Number 4, a plant protein diet does not allow carcinogens to cause cancer development in the body, and it will not cause foci or tumor growth. Thanks for watching.